Welcome or welcome back to 3 Inquisitive Kids. This is our last video of this entire chapter. It's going to be very quick and we're going to be doing a few more problems on area and probability. So this was our course outline for this chapter. In this unit we learned about probability, introduction to probability, and some basic problems. Our learning goals for today is the same as the last video. It's to understand the calculation of the probability of an event related to area and be able to use probability to solve problems. The picture shows a spinner. What are the probabilities that the pointer will land in the purple and red areas? You can see that we have a circle, and this angle here is 120 degrees. What is the probability of the pointer landing in the purple area, and what is the probability of the pointer landing in the red area? This problem is slightly different than what we've been doing before, so this might require a little bit more thinking. The area of event A is the numerator, and the total area is the denominator. So we can first split the red area into 2 equal parts. So the entire spinner is split into thirds. 1/3 is purple, and the other 2 are red. So the probability of landing on the purple section would be 1/3, and the probability of landing on the red section would be 2/3. How do we know to split this entire circle into thirds? Here we have our purple section, and it's 120 degrees out of 360. And when you simplify this fraction, you get 1/3, which means that the purple section was already 1/3 of the entire circle. What are the probabilities that the pointer lands on the red area and the blue area? But it's still the same thing. What is 110 out of 360? Well, that would be, when you simplify, 11/36. So that's the probability of landing on purple. And then the probability of landing on red is what's left. So 36 minus 11 is 25. So the probability of landing on red would be 25/36. Here's some practice. At a cross-section, the traffic lights shine 20 seconds red, 60 seconds green, and 3 seconds yellow. Is a person more likely to encounter a red light or a green light? And what is the probability of him encountering a green light? So it's more likely for Combin to encounter a green light because that's a light that shines the longest time. The probability of him encountering a red light would be 20 seconds over our denominator, the total number of seconds. So instead of 40 here, it's actually 20 seconds, which means it's 20/83. That's the probability of Combin encountering a red light. Example 2, the spinner is divided into 7 equal sections. The probability of the following events are blank, blank, and blank. There are 7 equally possible outcomes because all these sections are equal. The probability of landing in red would be 3 out of 7. The probability of landing in red or yellow would be 5 out of 7. And the probability of not landing in red would be 4/7.